look at the terminologies you would often come across in biostatistics. The first we have is population. Population simply means the totality, the entirety of any observable trait through which the researcher wants to make inference from. I come again. Population simply means the totality of every observable trait or characteristic in which the researcher wants to make inferences from. So my population could be the total number of, let's say, nursing students in UNICA. That's a population. You cannot examine every nursing student in UNICA for a particular research, but your concern is nursing students. So, like we said for the definition, every observable feature through which you want to make inference from is your population. Note that populations are generalized in a research, and we are going to explain that using the next terminology, which is sample. Sample basically is seen as the fraction or units for a population for study. So I have a population which most likely I cannot cover, maybe due to cost, due to numerical value. I take a fraction from that population. That is what denotes sample. Sample is what researchers use. Your particular focus may be the entire department or the entire students in nursing department in UNICAL, but due to costs or the numerical strength of the students there, you take a fraction. Let's say final year student, let's say you take 200 final year students in nursing department of UNICAL. So that is a sample. A sample, once more, is a fraction of the population of study by the researcher. The next we'll be looking at is variables. Variables from the word varies, changes, right? Yes. So a variable is simply any feature that varies from person to person. We are going to tag variable with another terminology called constant. Yes, it should go hand in hand. We are going to define variables and we are going to define a constant. Variable, like I said, is a feature that differs from person to person, place to place, object to object, event to event. Anytime there's a discrepancy, dichotomy in what you're looking for, or in a particular research, it is called the variables. A constant is the opposite of a variable. Constant is fixed. For example, I'm making a research on female lactation in Akpabio local government. That will not be considered, let's say the females there will not be considered a variable. Why? Because it is constant. It does not change. Remember, variables varies, from the word varies, changes. But a constant is fixed. You're doing a research and then there is no different audience. So it is considered as a constant. So back to variables. Variables classification or classification of variables. A variable generally can be categorized or classified into two. We have qualitative and quantitative. The next we have is independent and dependent variable. So let's look at them individually. The first we have is qualitative, and then we have quantitative. Qualitative can also be called category. Quantitative can also be called numerical. Take note, I either call them category or categorical, categorical variable, or I call them qualitative, or I can call them numerical or quantitative. So let's look at what they entail. Qualitative, talking about qualities, features, what you can see. So a qualitative variable is simply any variable that is not numerical but differ from person to person. It is the qualities or any observable trait seen that is not numerical. Underline the word non-numerical. Take note. Examples of qualitative variable include skin color, eye color, gender, and lots more. Any feature or characteristic that differs from person to person. We have height. Okay, height will not. That will lead me to asking this question, which would be a food for thought. If we have defined qualitative variables to be characteristic observed that is not numerical, so you answer this: would height and weight be under qualitative variable? The answer should be no. Why? Because we would have a numerical figure here. So this is not an example of a qualitative variable, although it varies. It varies, right? Yes, it does. So it is not a qualitative variable because it has a numerical figure, a numerical value in it. Okay, for quantitative variables are simply variables that have numerical values. They have numerical values, and this is where this can be fit into. So we have height, let's say 12 meter tall and 14 meter tall. We have weight 2 kg and 5 kg. You're seeing that they are different. We have age 15 years old. Any feature that varies but has numerical value, any feature that varies but has numerical value is termed a quantitative variable. These two types of variable have subdivision, which will be the next thing we'll be looking at. Okay, so this qualitative variable can be subdivided or subclassed into ordinal and nominal variable. So we can subdivide this as ordinal or nominal, and then the quantitative can be subdivided as discrete or continuous. Discrete or continuous variable. So let's look at what ordinal variable is. Ordinal. And then we look at what nominal variable is. Let's start from here. A nominal variable is any variable that does not have ranking. A nominal variable is any variable that does not have ranking. All of these are examples of nominal variables. Skin color, eye color, gender, they are all nominal variables because they are no ranking, right? Yes. So, but for ordinal variable, there are rankings. Although they are different, remember when you're talking about variable, you're talking about differences, variation, varies. So, for ordinal variables, they are ranking. For example, educational level, a person's educational level, or let's say educational level of a set of persons. Under educational level, we have, let's say, the nursery, we have the primary, we have the secondary, we have the tertiary. So you can see that this has ranking. Obviously, this has ranking. From nursery to primary, it is following a systematic pattern. Take note of that. An ordinal variable follows a systematic pattern. Let's say, a disease like cancer. Cancer is considered to have 4 stages. So the first and second must precede the third. You cannot just jump over to that. it is a systematic pattern. Let's say cancer 1, 2, 3, and 4. So all types of variation that has ranking. Take note, that's the underlying key point under ordinal scale. The ranking there means it is systematic. It follows a particular pattern. It's termed ordinal scale or ordinal variable. You can give me more examples in the comment section. Then for nominal scale, any like color, blue, red, white, green, orange, they are colors. There are no ranking there, but they are different. There are no ranking and they are different. This has ranking and is still different. So the bedrock of a variable is that there must be differences. There must be differences. And for discrete or for qualitative variable, which is considered to be subdivided into discrete and continuous. A discrete variable is a numerical variable that is fixed. That the number is fixed. While for continuous, it varies in range. It varies in range. So the values given here or gotten from this varies in range, while this is fixed. Let's begin with continuous variable. An example of a continuous variable could be height. Height. You see that height varies. Height varies. It is not fixed, right? It is not fixed. So discrete. For discrete variable, it is fixed. What you should take note of between the two is that for continuous, that's one memory factor you can use to remember it. For continuous variable, it is measured. Every variable that is measured is under continuous. Height, weight, body mass index, temperature, they are measured, right? So they would obviously be different. Anyone that's measurable. While for this, anyone that you can count. Let's say I walk into a ward, the number of patients in the ward, they are 10, it is fixed. Let's say this is a ward that has a maximum of 10, and I walk in and there are 10 patients. That's a fixed number. Let's say the number of people in your family, there are 5. That's fixed. That's fixed. And lots more. Any variable that is fixed and then requires counting, you can obviously see the difference by mere counting, is seen as a discrete variable under quantitative. And for continuous, there must be continuation. It varies, and it is measurable. So that's it for variables under qualitative and quantitative. The next we have is independent and dependent variable. The independent and dependent variable. So we'll still use a research. In a research, let's give an example of a topic. Let's say socio-economic factor influencing the rates of STIs in Calabar South, Calabar. Let's give a topic like this to denote an illustration or an analogy for independent and dependent variable. An independence variable is being manipulated by the researcher. So it is the researcher that manipulates the independence variable. So in this case, the socio-economic factor is the independence variable because it is what the researcher manipulates, or the researcher can change it to socio-cultural and amongst others. There's always a manipulation by the researcher for independence variable. The independence variable you should take note of is independent, and we have dependent. This is referred to as the presumed cause. And then the dependent is referred to as the presumed effect. So, what does socioeconomic factor have to do in the influencing of STIs in Calabar South, Calabar? So, you would now see that the STI's outbreak is dependent on socioeconomic factor. The STI's outbreak is dependent on this, so it is seen as the presumed effect. The presumed effect. So a cause leads to an effect. If I am cooking, for example, I have my firewood. I have my firewood here, and then my pot of food on the fire. Continuous burning of my firewood, that is going to lead to something. If I continuously burn my firewood, I'll have charcoal as a product. I'll have smoke as a product. I would have ash as a product. And I have my firewood here. So this can be used as a backcut to remembering independent and dependent variable. The firewood is the presumed cause. Let's say the firewood and the fire, because they go hand in hand. Firewood, fire. Yes, so this is the cause and this is the effect. So this is the product of this cause. So without this cannot be gotten. That is why it is dependent. The word dependent simply means rely. So it is the effect relies on the cause. The effect relies on the cause. There cannot be an effect without a cause. That is why it is termed an independent and dependent variable. And of course, you should still take note of the fact that there must be variation, since we are talking about variables. So that is it for variables and constant. We say constant simply means any feature that does not change. Any feature that does not change. It is the direct opposite of a variable. The next we'll be looking at is data. Data are simply numerical facts or raw facts. Better still, data are raw facts that are gotten from sources. So data are raw facts. Take note of that. And we still have subdivisions like qualitative, and we have quantitative data. It can be interchangeable with qualitative and quantitative variables. Qualitative data are numerical data. They are raw facts that are numerical. Quantitative are raw facts that are not numerical. They are not numerical. Take note of that. The only difference between data and the variables is that variables changes, but the characteristic is different. The characteristic of this is that it is non-numerical, while for this it is numerical. And the same thing applies to this. This is numerical data and this is non-numerical data. Take note of that. The next terminology we'll be looking at, parameter. This is number 5. Parameter and statistics. Simply put, a parameter is the numerical value of a population. The numerical parameter is the numerical value. It is the numerical value of a population. Let's say the total patients in a hospital, total patients in UCTH, University of Calabar Teaching Hospital. Let's say total patients in University of Calabar Teaching Hospital. That's a parameter. Let's say they are 537. That's the value, or that's the parameter here. That's the parameter here. Since my population is for the total patients here and the value is 537, it is referred to as a parameter. Parameters are simply numerical. Numerical is numbers. So the number attributed to a population is the parameter. For statistics is referred to as the numerical value of a sample. As parameter is to population, so as statistics is to sample. PPSS. Parameters are numerical values of population, and then statistics are numerical value of a sample. Let's say this is my population. Let's say My target audience is patients in a male medical ward, and the total number of patients in the male medical ward in this population is 35. 35. So since I'm concerned about male medical ward, male med ward, and I have a total number of 35, it therefore means the statistics in this sample is 35. It is just the numerical value of a sample. Statistics is to sample, parameters is to population. Take notes. A sample must be a representative of your population. A sample must be a representative of your population. Remember, the population is every patient, and then I am now laying my focus on male medical patients. Yes, or male medical patients. It is a representative of this. Take note, I cannot go and get a patient in a different hospital. That would defile what a sample is. Remember, a sample is a fraction of a population, while a population is the totality of any observable traits that through which a researcher wants to make reference or inference from.